Good morning, everyone. On behalf of Physics Made Easy Kota, I am welcoming you in the next part and the last part of the chapter Electric Charges and Field. There are three types of the charge distribution. First one is a linear charge distribution in which the charge is uniformly distributed over the line. To understand this, let us take a small amount of the charge dq that is distributed over the portion of the complete length, that is the dl. Here lambda is a linear charge density. So the df, apply the formula. Why we use the df? Because we are going to calculate the force for the small charge. So instead of taking the capital F, we are using here small df for the small charge distribution. Apply the formula, we get 1 upon 4 pi epsilon naught q naught. Here q naught is a test charge which experienced a force, multiplied by the dq divided by modulus of r square into r cap. Now for the calculation of the net force on the charge q naught due to this complete linear charge distribution, we can take a line integral. Second one is a surface charge distribution in which charge is distributed over the surface. Again we take the small amount of the charge dq. Here sigma is the surface charge density, ds is the small area in which dq is distributed. Again we apply the formula and calculate the df force. Then we calculate the net force on the charge q naught by taking the surface integral. The third one is a volume charge distribution in which the charge is distributed over the complete volume. So for this, first of all, again we follow the same steps that we have to find the charge distribution for the small age volume surface. Then we can find it completely by taking the integral over the entire surface. The next topic, that human body is a conductor. To show that charge can flow through a human body, in 1774, a person suspended with the help of insulator ropes was touched with a charged rod at his foot. Electric sparks flew from his face, hand, and a metallic rod held by him when the same was brought near the earthen metallic plates. Hence, this shows that charge can flow through the human body. Earthing. Earthing is a very important topic. This is a method by which the charges are shared between a charged body and a earth. Suppose the metallic body of an electric iron gives shock if touched barefooted. If the body of the iron is connected through a conductor buried deep into the earth, the charge present on the body of the iron get transferred to the earth, which accept the charge, be good and a huge conductor. The conductor used to connect the body of the iron and the earth is known as earth wire. So metallic bodies of all the electrical things or electrical appliances are earthened from the safety point of view of the appliances as well as the user. The supplier ensures the availability of a third wire, which is known as the earth wire, to the consumer. However, the consumers are advised to have their own earthing. So for earthing, a deep pit is dug in the earth till soft moist earth is obtained. A thick metallic plate connected to a thick conducting ground wire is put into this pit. Charcoal, common salt, lime, etc. are also put into the pit for better results. Hence, grounding has a great importance in electrostatics. It ensures safety of the appliances as well as the user. Grounding or earthing is representing by this symbol. Next one is a numerical from your NCERT textbook. What is the force between the two small charged sphere having charge 2 into 10 raised to power minus 7 coulomb and 3 into 10 raised to power minus 7 coulomb placed 30 centimeter apart in air? So the charge on the first sphere is taken as Q1, charge on the second sphere is taken as Q2, and the distance between the spheres is denoted by R. The value is given in a centimeter. We can convert it into the meter. Then we apply the formula of the electrostatic force. That is, the electrostatic force between the spheres is given by F is equal to Q1 Q2 divided by 4 pi epsilon naught R square. Here epsilon naught is a permittivity of a free space. We know the value of 1 upon 4 pi epsilon naught is 9 into 10 raised to power 9 Newton meter square per coulomb square. Put all the values in the formula of the electrostatic force and we get the answer 6 into 10 raised to power minus 3 Newton. So this force is small between the two small charged spheres, and this force is positive, and hence it shows that the charges are of same nature and the force between them will be repulsive. This is for the chapter number 1. Now in the coming video, we are going to learn about the chapter number 2 of the class plus 2. Hope you like the videos of this chapter. Thank you. Take care. Have a nice day.